Now we're going to start section 5.2, polynomials, and we're also going to use function notation for the first time. And then we'll learn how to add and subtract polynomials. So a polynomial is a collection of terms. Polynomial is made up of terms. And a term has a coefficient. It can have a variable, and it can have an exponent. So 3x squared is considered a term. The 3 is the coefficient, the x is the variable, the 2 is the exponent. Negative 5x squared y to the third is a term. Negative 5 is the coefficient. X is a variable, 2 is the exponent. Y is a variable, 3 is the exponent. So that's a term. Polynomials, poly meaning many, nomial is a collection of terms. Terms are separated by the plus and the minus sign. So if I have 5x squared minus 2y to the third, this has two terms. Here's my first term, 5x squared, and here's my second term, negative 2y to the third. That negative goes with that 2. And we have some common polynomial names. Let me start with a monomial. Mono meaning one. A monomial has only one term. Negative 17x to the fifth y to the third. That would be considered a monomial. A binomial, bi meaning two, has two terms. X plus 7. The first term is x. The second term is that positive 7. A trinomial, not surprisingly, is going to have three terms. 4x to the third minus 5x plus 1. That would be considered a trinomial. My first term is 4x to the third, my second term is negative 5x, and my third term is that 1. Anything bigger than three terms is just called a polynomial. No special name for four or more terms. It's just called a polynomial. Now the degree, every term, I'll go back to this, every term not only has a coefficient, a variable, and an exponent, but every term will also have a degree. And the degree of the term is you add all the exponents for that term. So right here, this is a monomial because there's only one term, and it would be degree 2 because we have the second power. This is also a monomial, but it would be degree 5 because 2 plus 3 is 5. This is degree 2. This is degree 3. Every term has a degree. And every polynomial also will have a degree. The degree of the monomial is the degree of the term, the degree. The degree of the entire polynomial, or the degree of the trinomial or the binomial, is the highest degree of any terms. So we're going to go through several examples. I know it's a lot of vocabulary now, a lot of new vocabulary, but we'll go through these examples. So let's start with our lecture notes. I've briefly discussed monomial, binomial, trinomial, and the degree of a polynomial, and we'll look at the polynomials as functions with function notation. And then we can simplify polynomials by combining like terms. And then we can also add and subtract polynomials. So find the degree. These are terms, individual terms. The degree of this first term would be 3 because that's the only exponent in that term. The degree of this term is going to be 6 because 2 plus 4 is 6. That's a 6th degree monomial. X is really like x to the first, understood, so this is a first degree polynomial. And lines are first degree polynomials. Okay, so this is x to the first, y squared, z to the fourth, so this is degree 7. And then how about a constant? This was like 9 times x to the 0. Remember, anything to the 0 power is 1. A constant is degree 0. A constant is degree 0. The exponent is raised to the 0 power. So why don't you try practice 1 and go ahead and find the degrees of individual terms. Now looking at classroom example 2 here they want us to find the degree of the polynomial and say whether it's a monomial, binomial, trinomial, or none of those names, just polynomial. All right, so this term, the first term is negative 6x. That would have degree 1. The second term is 14, and that has degree 0. So the degree of this polynomial is degree 1. That's the larger. And since there are 2 terms, we would say this is a first degree binomial. A binomial, and the degree is 1. Degree 1 binomial. All right, let's look at this polynomial here. This has 1, 2, 3, 4 terms. The degree of this first term is 1. The degree of this second term is 6. The degree of this third term is 4. And the degree of this last term is 0. Since the biggest degree of any of the terms is 6, we would say this is a 6th degree. 1, 2, 3, 4 terms, we would just call that a polynomial. A degree 6 polynomial. It's not a binomial, a monomial, or a trinomial. It's a 6th degree polynomial. And here we have 3, 1, 2, 3, 3 terms, so that's going to be a trinomial. This is degree 2, this is degree 1, this is degree 0. We would call this a 2nd degree trinomial. Or a trinomial degree 2. So why don't you go ahead and start practice 2. Let's move on to classroom example 3. Here they want us to, for this polynomial, they want us to complete this table. So my first term is negative 3a squared b squared. My second term is 4ab. My third term is negative 2b squared. My fourth term is a. And my last term, my fifth term, is negative 5. 1, 2, 3, 4, 5. Polynomials are separated into terms. Terms are separated by plus and minus signs. All right, so let's look at this first term. The coefficient is negative 3. And the degree of this term is 2 plus 2 is 4. The coefficient of this second term is a positive 4. And this is to the first degree, and this is to the first degree. So the degree of this term would be 2. 1 plus 1 is 2. My third term, the coefficient is negative 2. That's also a second degree term. This a is like 1 understood as the coefficient, so the coefficient is a positive 1, and it's like a to the first. So both the coefficient 1 is understood and unwritten, and the exponent, or the degree, is 1, not written and understood. And the coefficient of this last term is negative 5. And remember, this is like negative 5x to the 0. That's 0. So we would call this entire polynomial, since the highest degree of any term is 4, this polynomial is a 4th degree polynomial. All right, so why don't you go ahead and try practice 3.